You are welcome to this class. Today we want to talk about indices. It's part of the Waec syllabus. We want to talk about indices. And in this topic, we're going to look through the laws of indices and some of the examples under under indices. So that when we practice some of the examples with the laws, we get to have a better understanding of what we call indices. But before we begin the indices, there is a prior knowledge that we need to have before coming to indices, and that's what we call a prime factorization. Prime factorization. That means before anyone could say he wants to study indices, he has to have a better understanding of what we call a prime factorization. I call it prime factorization. Prime factorization. Prime factorization. And what do you mean by prime factorization? Prime factorization is about writing a number, expressing a number in its prime. But when you're expressing it, it has to be in an index form. That means if I'm giving a number, let me say I'm giving a number 36. If I'm expressing number 36, that means 36 will be 2 multiplied by 2 multiplied by. So if 2 goes here, it will be 18. 2 in 18, that will be 9. 3 multiplied by 3. If you see that these 2s and 3, they are all prime number. But if you leave it like this, it's not prime factorization. We have to write it in index form. So that means 2 times 2, it means 2 in 2 places. That's 2 raised to the power of 2 times 3 raised to the power of 2. That means we can write 36 in prime factorization as 2 raised to the power of 2 multiplied by 3 raised to the power of 3. That will be 3 raised to the power of 2. That means what we are saying that 2 have an index. We can call it power. The 2 up here is what we refer to as index or power. The same goes here. And the 2 at the down here, or the 3 at the down here, is what we refer to as the base. The both at the top here, we refer to as index, or you can say it is called power. And some, they still call it exponents. But the 2 and the 3 here is called the base. So from this knowledge of prime factorization, it will help us when we are trying to express a number in indices, because index is a singular for indices. Indices is the plural of index. So that means when we have more of this now, we are referring to as B and indices. You get us now. So the knowledge of prime factorization is required when we are dealing with indices. And the basic thing in the prime factorization is to express a number as a product of its prime. That's a better way to put it. To express a number like 36 now, I've expressed it as a product of its prime. You see, 2 is a prime number, 3 is a prime number. So we should not forget that. This is the way to put it. 2 raised to the power of 2 multiplied by 3 raised to the power of 2. The 2 and the 3 here, we call it the base. But the 1 at the top, we call it the index or the power. We should know this when we are dealing with indices. When we are dealing with indices, we know it better. But don't forget that the 1 at the top is called the index or power. And the 1, like the 2 and the 3 here, is what we call the base. It's what we call the base. It's what we call the base. Now, moving to indices proper. Moving to the indices proper now. What do we say our indices means? You can see, we say an index is a convenient way of writing a repetitive multiplication. You can see in the case of that 36, the plural of index is indices, and that's what we want to discuss. So index tells you the number of times a number is multiplied by itself. So here, for example, now if I say m to the power of 4, what I'm saying that I multiply m 4 times. M multiplied by m, multiplied by m, multiplied by m. So you see m is multiplying itself 4 times. That's the meaning of m raised to the power of 4. So m here is called the base. And the 4 at the top there is called the what? The index or the power. The index or the power. So we should not forget that. M here is called the base. The 4 here is called the what? Index. It's called the index or power. Index or power, because we are going to need those two things when we are trying to write the law for indices. If you don't understand the base and the power, it becomes more complicated. So don't forget now, if I write 2 raised to the power of 3, what I'm saying here, the 2 here is my base, and the 3 at the top here is my power. The 2 here is my base, or I call it index. The 2 is the base. The 3, the one at the top, is called the power or the index. Please don't let us forget that. Now, the next thing to do is to move to the laws of indices. Laws of indices. Now, the first law of indices is called a multiplication law. Multiplication law. That means when you have a number in terms of index now multiplying itself. Now, what are the general rules that govern this multiplication law? Let's assume, before we use variable, before we use a number, let's assume we have a variable. Let me say x raised to the power of a multiplied by, that's what we call the multiplication law, x raised to the power of b. You see that in this, x here is the base, a here is the power or the index. These are multiplication sign. X here is also the base here, and b here is the power. We see something is common to these two things. That means the base is the same. X is the base here, x is the base here. So those are the things that you need to look for when you are doing indices and when you are applying any law of indices, especially for this first one. I call this multiplication law. Now, what we are saying here now is, you see the base here is x, the base here is x. So before you can apply a multiplication law, that means the first thing you need to check is the base the same? Is the base the same? So if the base is the same, you can now apply your multiplication law to the powers. But if the base is not the same, that means this law is not applicable. What do I mean? Your multiplication law is saying that once the base is the same, we pick one base and we add the power. Pick a base and we add the power. The power here is a and b. So that means when we add that, we say a plus b. So the multiplication law is saying that when you have two variables of either the same power or different power multiplying themselves, x raised to the power of a multiplied by x raised to the power of b. See here, they have the same base. And since they have the same base, we can apply our multiplication law. Don't forget, when you apply the multiplication law, the first thing you need to check for is that multiplication must have this, what you are multiplying must have the same base. If you don't have the same base, that means the law is not applicable. You need to apply another thing. So you pick one base and you add the power, a plus b. That means multiplication turns to addition when you are adding the power, not that you are multiplying the power. Let's look for example. First, let me say 2 raised to the power of 3 multiplied by 2 raised to the power of 2. Now, for us to know that this law is true, let's go through our number process. We say 2 raised to the power of 3 means 2 in 3 places, like what we have here, m raised to the power of 4, that means m in 4 places. That means 2 multiplying itself in 3 places. That means I will have 2 multiplied by 2 multiplied by 2, and this multiplication 2 in 2 places, that means I will have 2 in 2 places, 2 times 2. So if I count this 1, 2, 3, 4, 5. So the answer here is 2 to the power of 5. This is a normal way. For you to know that the law is also true and it helps us to simplify without going through this stress, is since we know they have the same base, 2 raised to the power of 3 times 2 raised to the power of 2. They have the same base and the base here is 2. So I can pick one base, 2 raised to the power of 3 times 2 raised to the power of 2 is equal, since they have the same base, just pick one base and add the power, 3 plus 2. You see, we see I have the same thing, 2 raised to the power of 5. This one is more simpler than this. I'm just showing you to see that we arrive at the same answer. So one of the things to note when you apply your multiplication law is the base must be the same. The base must be the same. The base must be the same for your multiplication law to apply multiplication law. The base must be, you see the word must, be the same. To apply multiplication law, the base must be the same. If the base is different, you cannot apply your multiplication law. That means we need to deal with it with another, we need to go with it with another approach. We need to deal with it with another approach. So that's our multiplication law. Let me give us one simple example again. Now let's say, for example, we have something like 2x raised to the power of 4 multiplied by 3x raised to the power 2. Let's just have something like this. You will see here that it's a little bit different from your multiplication law because your x raised to the power of 4 here have a coefficient of 2, and your x raised to the power of 2 has a coefficient of 3. You can still apply our multiplication law because if you look at this, 2 and x raised to the power of 4, the operation between them is still multiplication. And 3 to x to the power of 2, the operation between them is also multiplication. So we should not forget our normal basic thing that we learn from the junior class. Because 2 multiplied by 3 is 6. So that means we have 2 times 3, that means you have 2 times 3 multiplied by, now because x to the power of 4 and x to the power of 2 is the base here is still x, and the operation there is still multiplication. X to the power of 4 times x to the power of 2. So 2 times 3 is 6. X here, that means they have the same base. I pick one base and I have the power 4 plus 2, and that gives me 6. So the answer is 6 to the power of 6. 6 to the power of 6. So don't let us forget that what we know, your previous knowledge, will still be required in what we are doing. Don't let us forget that. Now let's go to the second law. We call it divisional law. Divisional law. The same thing that happens to your multiplicational law also happens here. Before you can apply your divisional law, that means the base must also be the same. Let's say we have x to the power of a divided by x to the power of b. You see now the base here is still the same. But what they are saying, when you have divisional law, what they are saying is you subtract the power. That means I will pick one base, x to the power of a minus b. Please, it's not b minus a, because the first variable you have here is x to the power of a. Or they can write it in this form, x to the power of a divided by x to the power of b. It's still the same thing. It's x to the power of a minus b. So also your divisional law, the base must be the same. The base must be the same before you can apply this law. The base must be the same. The base must be the same. For example now, if you have something like x raised to the power of 5 divided by x raised to the power of 3. Now if you follow our normal conventional law, x raised to the power of 5 makes x in 5 places. Don't just forget x times x times x times x times x. That's saying divided by x raised to the power of 3 makes x in 3 places. X times x times x. So that means x, one x, we cancel one x here. Another x, we cancel the one down. Another x, we cancel another x. So what we have left at the top is 2x. That means that gives us x raised to the power of 2. You see, now our normal way. But this one is a little bit stressful. We just apply our law of indices, our divisional law. Say x to the power of 5 divided by x to the power of 3. What we are just saying is, since they have the same base, you can pick one base and subtract the power, 5 minus 3. And that gives us x to the power of 2. See, we arrive at the same answer, but this one is more simpler. It's more simpler. It's more simple. Let me give another example so that we don't forget what we know from our junior class. If I had, let me say another example, like let's say 9x6 divided by 3x4. You see now, 9. So easily we can say, since it's division, I can say 3 here 1, 3 in 9, 3. That one cancels out. And we know my x to the power of 6 and x to the power of 4. X, they have the same base. And the operation there is division. So I can apply my division law and pick one base, x, and subtract the power, 6 minus 4. And that gives me 3x raised to the power of 2. So don't let us forget our division when we are dividing also. Now let's move to the third law. We call it zero index law, or we can say zero power law. That means if we have a variable or a number raised to the power of 0, if I say x raised to the power of 0, what it means is 1. Any variable, any number, apart from 0 itself, raised to the power of 0, will give us 1. If I say 5 raised to the power of 0, it gives me 1. If I combine number and variable together, if I say 5xy, and everything here is raised to the power of 0, everything will still give me 1. If we say 1000 raised to the power of 0, it will still be 1. So don't forget, any variable, any number, any variable Don't forget, when we say variable, variable means a letter, an alphabet. In mathematics, we call it variable, like X, Y, P, Q. We call them variable. Any variable, or I say number, apart from zero itself, apart from zero itself. Do you get now? That means if you use any variable or number apart from zero itself to the power of zero, that means we always have a unity, one. We have one. So that means no matter how they combine it, it will always be one. If I say X, Y, Z, W, all raised to the power of zero, it's still one. If I say 5x cubed y squared, all raised to the power of zero, still give me one. Don't forget, a variable or a number apart from zero itself, raised to the power of zero is one. Don't say, no, what do I mean by don't use zero? You can say zero raised to the power of zero. Now, this one is more advanced a little bit. Sometimes we call it undefined or indeterminate. This one is undefined or indeterminate. Undefined or say indeterminate. So don't use zero raised to the power of zero. So any variable, take it either x, y, any variable. That means any alphabet we use in math, we call it variable. Raised to the power of zero, that will give us one. And any number itself apart from zero raised to the power of zero will give us one. So the fourth law we are going to look at is what we call a product index or a product power law. What's this one saying? That means when we have, let me say, x raised to the power of a. And this x to the power of a, we have it also to the power of another thing. Let me say b. What we are saying here is a product index. So that means a here is our index, or we say power. B also index, or we say power. It's just that we are multiplying it. So that means we say x raised to the power a, b. That means a multiplied by b is what? A, b. For example now, if I say 2 raised to the power of 2, everything raised to the power of 3. So what I'm just saying is that for easy answer, just multiply the power. 2 multiplied by 3, that's 6. Just a 2 to the power of 6. Now, if you want to go to our conventional way, what we are saying 2 to the power of 2 or to the power of 3. What does it mean? That means they are saying we should write 2 to the power of 2 3 times. We are saying 2 raised to the power of 2 times 2 raised to the power of 2 times 2 raised to the power of 2. That's what it means. And now if you look at this now, you can say it's also a multiplication law because these three have the same base. The same base. The base here is 2, the base here is 2, the same here. So I can pick a base and add the power. 2 plus 2 plus 2. And that will give me 2 raised to the power of 6. So going through this and this, so this one is more easier to get. So when we have a power multiplying itself, how we call it product index, or we call it power law. So easiest to just do it this way. Let me give an example that looks a little bit tricky. Where I say 2y all raised to the power, sorry. Now, if I say 2 to the power of 2y all raised to the power of 2. Look at this. It's a little bit. What we are saying here, if you just write a variable, you see here there's nothing on y, but it means that it is y raised to the power of 1. Anytime you see a variable, just either they say y or x, or that means that variable is to the power of what? 1. Now 2 raised to the power of 2. Y raised to the power of 1, everything raised to the power of 2. The easiest way to go about this, 2 raised to the power of 2 is 4. Y or square, that's what it means. So now, what you just do here now is, since we have a number and a variable inside the brackets, and they are also the power of 2, we distribute that power to each element in that bracket. So what you are saying is, we say is 4 to the power of 2, y to the power of 2, and 4 to the power of 2, that's 16, y squared. You see, along our product's power law. Because what we do here, we are multiplying the powers of 4, which is 1 times 2 is still 2, and the power of 1 here, y here, which is 1 times 2 is still give us 2. So when we have something like this, that means everything inside that bracket, every element, either number or the variable inside the bracket, we own this power, everything. So that means what I'm trying to say is, if I say x, y, z, all to the power of 2, what I'm saying is that every variable inside this bracket owns this power of 2, x to the power of 2, y to the power of 2, z to the power of 2. That's what this means. That's the meaning. That is the meaning. Now, let's go to the fifth one. We say negative index law. A negative index law is talking about when the powers is negative. That means if I have, let me say a raised to the power minus 1. That means when the power is negative. When the power is negative, a raised to the power minus 1 means, the minus here means 1 divided by a raised to the power of 1. Now, this is how we arrive on this. Anytime you see a negative power, the negative there means 1 divided by, and you are left with that number, that is a raised to the power of 1. Now, let me give another. If I have a raised to the power of minus 2, what it means is 1, that negative is 1 divided by, say, a to the power of 2. Now, this is the trick behind this thing. Let me first pick this a to the power of minus 1. Now, how do you arrive at a to the power of minus 1? Now, from our division law, let's say, for example, I have a to the power of 2 divided by a to the power of 3. Now, using your normal conventional way and applying our law of divisional law, we see what I'm trying to say. Now, this is the same thing as a to the power of 3 is the same thing as a multiplied by a divided by a raised to the power 3 is a multiplied by a multiplied by a. Now, if we carry this out, a here we cancel a, another a we cancel a. So that means what is left at our numerator here is just 1 divided by what we have here is a. So this is 1 over a. When we use our conventional way. But when we use our divisional law, what we say is a, since it's a raised to the power of 2 divided by a to the power of 3. Our conventional law says this, they have this, our divisional law, since they have the same base, you can pick one base and subtract the power and say 2 minus 3. And this gives us a raised to the power 2 minus 3 is minus 1. So do you see that this one gives us minus 1? And this one is 1 over a. So that means the answer here and the answer here has to be the same.